All right, so we're going to talk about in section 6.9 here, we're going to talk about a special number that always comes up, and that's 2.71828, okay? It's kind of the forgotten number. Like everybody that goes through high school has learned about this number, and it's designated with a specific number, with a specific, I should say, symbol. But usually most people, when they go through high school in geometry, they'll learn about, and they'll always remember this, and this is crazy to me. So they'll always remember this number. So that's pi right there. Most kids know that. When they went through geometry, they figured out what pi was, and pi was 3.14, blah, 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 blah. It was a whole bunch of different values, okay? If I look for it on my calculator, and we look for pi. Everybody see that pi symbol? It's on my calculator. And if I hit enter, 3.141592654, whatever. Okay? People remember that. Your parents will remember that. If you're like, hey, what's pi? And they'll be like 3.14 because it's related with circles. Okay? And pi is a irrational number, which irrational means it doesn't stop. It goes on and on and on. Okay, so if somebody says you're being irrational, it means you're not stopping. You're just going on and not thinking about anything and just being irrational. Okay, so pi was that number. That was that special magical number. Now, in Algebra 2, there's another magical number that's irrational that people will run into, and it's this exponential function, and it's base e. So e also has a number like pi does. Pi is 3.14, and e's value is 2.718. So when we work with that, and on my calculator, if I bring it up, it has an option for E, and it's right here. There it is. And if I hit enter, it'll say, yep, E is 2.718. So it's a special number. So we're going to work with that. It's a naturally reoccurring number, just like pi is. Okay? It doesn't stop. So just because it stops on the calculator, it's irrational. It goes on forever. Okay? So 2.718. So it's also an irrational number. So this is what we're going to talk about today because it's special. It's a special case. It's a special scenario. Okay? So today, and in fact, everything I think I just said in that little, how long has this video been? 2 minutes and 38 seconds so far. I've said right here. Okay? E is an irrational number. It's got a value of 2.718. Okay? You're going to see it when we start talking about compound interest problems. It's a naturally occurring number. When things happen so fast, it's always going to approach this number. And we'll talk about that more in the future. Okay? Exponential functions with the base of 2.718. Remember, E is a value. Remember, E is a number. So exponential functions with a value of 2.718 are called a natural base. Okay? So E is a natural base. Remember, E is a number. This is a number. This is a number. So E is a number, okay, 2.718. So when you see log problems with base E, base 2.718, it's called a natural base because it's naturally occurring. Logs in base 10 are common logs. Logs in base E are natural. They naturally occur, okay? So here's an example of an exponential function in base E. So f of x equals 2.718 to the x power. So when you see E, just like pi, when you see pi, you think 3.14. So when you see E, I need you to think 2.718. Okay, we'll talk about more where it comes from here in the future. I just need you to get used to working with it. Why are we doing it now? Because it goes with logs, and it goes with exponential functions. So log functions with base E are called natural logs. On my calculator, there is a button that says log. You see it right there. And underneath it, it says ln. ln stands for the natural log. Okay? So log functions with base E are called natural logs. So this is something that looks like base E. Has a log there. But what they do is, since it's a naturally occurring thing, what they do is they write it like this. This is how we abbreviate it. So we can abbreviate these natural logs using what's called ln. Now I know that seems backwards, because it's natural log, n comes before L, but this idea was developed in another country from languages where they don't say the adjectives before what they're actually talking about. Okay, so we say blue car, so in some countries they say car blue. depending on how their language is spoken. So this is the natural log. They would say log natural. Okay, so that's why it's denoted like this. Remember, math is a language too. So we're going to rewrite those things. And we just need to remember how to rewrite things in exponential form and log form. So this is still an exponential function. So you can write this in log form. Since this is an exponential function, how do we write stuff in log form? We can go log 1, 2 equals 3. Your base is going to be what? Your base is going to be e. Logs are going to equal your exponents. So my exponent is going to come over here. My exponent was x, and the 24 is going to turn out to be your argument. So there, I've written that in log form. Kids, that is in log form. The only thing now is when we see this, when you see log base e, remember what we just talked about, we're going to abbreviate that as it's a naturally occurring log, so we're just going to call it ln. Okay, we're going to call it ln. So I'm just going to say ln of 24 equals x. So there you go. So you can abbreviate this. You can abbreviate this. Abbreviate. That's a big word for me to spell. So log base e abbreviated is just ln. If you want to leave it like that, you can go ahead and leave it like that. That's fine. Okay, the best part about this is there's an actual natural log button on your calculator. So if I wanted to figure out what ln of 24 is, I don't got to do this fancy like log 24 divided by log e, which you would on the change of base. So if you went log 24 divided by log of that naturally occurring number e, because remember on the calculator you got to change the base. So if I did that, we get this number, 3.17. If I just utilize the ln button right here, the natural log button, and I just type in 24, because that's what we know it's going to work with. Look, they come out to be the same thing. Hey, natural logs are actually easier to enter on the calculator, okay? They look ugly, but whatever. Don't worry about that, okay? So that's how I can rewrite it. So if I look at number 2, and I want to write that in log form, so log 1, 2, 3. The base is e, so it's going to be base e. Logs equal exponents, so the 9 is going to be what the log equals, because that was the exponent. The argument's going to be x. How can we abbreviate log base e? What did we just say? We said we could write this whole thing as the natural log of x equals 9. So they just ask you to rewrite it. Do you see up here it says just write it? It didn't say solve anything. It's just saying rewrite it. So there you go. I rewrote it. Okay. Below it, it says write each in exponential form. Okay. So if I want to write them in exponential form, let's just recall what the natural log means. It means this. Remember, we abbreviated the natural log because it came from log base e. I know it looks like log, right? Okay, log base e. And remember up here I abbreviated it? Well, where did that come from? Natural log came from log base e. It tells me to write this in what? Exponential form. So you're going to fill in exponential form the 3 little blanks. So e is staying at your base. Ooh, I picked yellow. That didn't look... Oh, can you still see that? Maybe you can still see that. I'm going to roll with it. All right. And logs equal exponents. So the 58 is going to come out to be your exponent. And the argument's going to move over to the other side. And this is now in exponential form. So we're just rewriting it. Remember, the whole idea of this section is to rewrite it. I'm not solving anything yet. Okay, now as some kids get faster with this, they'll be like, oh, that's a natural log. They're not going to have to write it so it has that log with a base e on it. What they're going to do is they're going to instantly remember that what is the base of the natural log? The base is actually base e. So are you going to be able to get here from here is what I'm trying to say. Can you just skip that step in the middle of writing it with log with base e? I don't know. If you can't, great. But if you can, hey, that's even better. Okay. So we know that logs equal exponents. So the x is going to turn out to be the exponent here, and the 6 is going to be your value that it equals. Okay. So you're just rewriting it. Just rewriting it. It says condense each into a single log. Kids, this ones are easy. These follow the same rules. Remember your log properties? Log properties still work. Your log properties, they still work. So what does that mean? That means I can use which property on this? I can use my property or my product property. When I see two logs that are being added together, how can I combine their logs into one? Well, with their powers combined, what can I do with the 3 and the 6? I can use multiplication. 6 times 3 is 48. So this would be the natural log of 48. If you don't believe me, if you're like, Thrasher, I don't think that works. Why isn't it just log base 19? Because there would be the value of log base 3 plus log base 16. There would be the value, I should say natural log. This would be the value of log of 48, the natural log. Hey, do you notice how these come out to be the same thing? So if you just typed in natural log of 3 plus 6, which is 19, if you just typed in the natural log of 19, did that come out to be 3.8? No. So actually, you just adding the 3 and the 16, even the calculator's like, that doesn't come out to be the same thing. But 3 and 16, if you know that they're being added together, you can quickly multiply them together. Properties of logs say you can multiply their arguments. So do you notice how it comes out to be the same thing? If you're the kid that just adds them together, calculator's telling you it's not the same thing. So in case you don't believe me, there it is. Okay. Expand each log. So let's go right underneath it. Okay, so expand it means go in the other direction. So what's happening with the 5 and the x? The 5 and the x are being multiplied. So that means what types of logs did it come from? That means it came from logs that are being added together. So they have natural logs, 5 and x, 5 and x. There, we expanded it. Expanding means pull it apart. It's like if I gave you a natural log of 48, I told you to go back to where it came from. You'd say, oh, natural log of 3 plus natural log of 16. Okay, awesome. Sweet. Okay, let's go talk about talk about how to do a problem where it requires you to use a natural log. Now, kids, you're going to use the same properties and rules that you were using for your exponential functions and your log functions. So the rules don't change. It's just got a different base. It's abbreviated different. It still means the same thing. Remember, 17 still means this. Log base e of 8x equals 2. So if you rewrite it so it looks like that, and then it shows you it's still the same old log, just abbreviating, just fancied up a little bit. Remember, how do we solve log problems? What do? We rewrite using what? We rewrite using exponents. So write it in exponent form. Okay? So what is the base? Our base was e. The 8x and the 2 are basically switching spots because remember logs equal exponents. There you go. Are you going to be able to go from this step to here? I don't know. If you can remember that the natural log has a base of e, if you can remember it's really the base e. So there's your base. We rewrite it. We're ready to go. Thrasher, I don't know what it is. Yes, you do. E is 2.718. Oh, yeah, that's true. So you can go 2.718 squared, or whether you have your phone's calculator, whether you have whatever, there's an option for E on your calculator. Mine is in the same location as the natural log. So you see the natural log, you see how there's an E to the X button right there? So if I bring that up, it already knows, it's like, dude, I need an exponent. It's got a little exponent blank on my calculator, like it knows it's going to be an exponent. So what is our exponent? Our exponent's 2. And we're going to get that. Now, if you're like, I can't remember that, okay, what did we say E was the same as? 2.718. Now, it's got a lot more decimals than that, but even if you did it this way and you squared it, you're still going to get 7.38. The decimals at the end are a little bit different, but that's because you cut some decimals off here. Remember, it's a long decimal, but if you kind of round it a little bit, you'll still be in the same ballpark. 7.38, 7.38, there's a 9 behind it, so I'd round that one up. This one's got a 7 behind it, so 7.39. So let's write this as 7.39. How do you finish that problem? What are you going to do with that 8 and the x? Because remember, you want to get x by itself. Kids, this is old math right here. Like getting here, you guys should be like, oh, nice. This was the new stuff. This right here is now old. How do you get rid of that 8 and the x? You're just going to divide. So I'm going to take both sides and divide by 8. So, Thrasher, are you telling me I need a calculator? Yeah. If you have your phone, if you have a smartphone, it has a calculator on it with all of these options. I can show you how to use it. What do you need to do? You need to log in and talk to me. Oh, I can't talk to you. That's weird. Okay, I don't know how else to help you. I can't reach through the screen. So if I take 7.39 divided by 8, I'm going to get like 0.92. Okay? You're going to get a lot of ugly decimal answers. Where these are leading us to is financial problems, and I can show you how this works. These actually are more applicable to your life than anything else that we do in this class. But since it's logs and natural logs, and your parents will have forgotten it, because a lot of people don't know how credit cards work and exponential and growth and things like that. That's where we're headed. Okay? All right, let's talk about number 21. Okay, so 21, remember, got a problem that has exponents in it. Got a problem that has exponents in it. So the 4 in the n, I know I can't do anything with that 4 in the n until we use logs on this. When you have exponents, you use logs. Even if it's got the funny base e. Even if that's funny to you. Kids, if you don't like e, I'm telling you right now, if you don't like e, just put 2.718 in there. Like if you can't handle the fact that there's a symbol there that represents the number, just put the number in there. You'll still do this the same way. I will? Yep. What's happening with 5 and 2.718? They're being multiplied. So what we're going to do is divide both sides by 5. So I get 2.718 to the 4n equals, I don't know what 5 divide or 95 divide. Oh yeah, it should be 19. Duh. Silly old man. So there you go. Remember, e is 2.718. You can put it in there. You don't have to. How do we solve problems with exponents? Oh yeah, Thrasher said we got to use logs. Okay, so let's use logs. So now the great part about this is, since this is a special base and this is e 2.718, since it's e, don't just use a regular kind of log, use your natural logs. Okay? E only goes with natural logs. So if you want, instantly, what some kids will do is they'll rewrite this, and they'll be like, oh, I need this, and I can have this, and replace them here. And what is our base? Our base is 2.718, which that's really just the same as e. What do logs equal? Logs equal exponents, so 4n is going to come over here, and you get 19. But what do we know about the natural log? I don't need to put that base in there. It's just, it's a naturally occurring thing. Okay? But, you're ready to roll. You rewrote it. Nice. Awesome. So, I'm going to type in natural log of 19, because I don't know what that is. Natural log of 19. There it is. Great. 2.9444444. 2.9444444 equals 4n. Now you probably don't even need to rewrite it. How do we get rid of the 4? We're going to divide both sides by 4. So I still have that option on my calculator. I still have that number on my calculator up here, right? See how I can copy and paste that? Oh my gosh, Thrasher technology is amazing. I know, I got a new phone today. I don't know how to use it. Okay, going to divide both sides by 4. Awesome. 0.73, look at the 3, what's behind the 3? Behind the 3 is a 6, so I'm going to round that up to 0.74. So n equals 0.74. Okay? So, what did you learn out of this video? I learned I'm more confused than I'm started. No, this is what you learned. You learned that if I see the new number e, then you are going to use your new type of log. If you see your exponential function, you're going to use natural logs. So if I see a function that looks like this, e to the x equals 14, I know I'm going to use natural log. Ooh, I see e, that means I'm going to use the natural logs in it. Okay? So, what if you see a natural log in the problem, well, these two are opposites of each other. If I see the natural log, you're going to use the special base number that we just talked about with e. So if you see natural log of x equals 3, then you instantly know that you're going to use e to solve it. Okay? So that's the only time you'll ever use these two. You don't use e with regular logs. You don't use natural logs with regular numbers. They go together. They're their own special case. They go together. E goes with the natural log goes with e. Okay? So if you see something else that's not an e or a natural log, you're not going to use it. So if you see something that looks like this, and it has log base 7 of x minus 3 equals 2, kids, don't use e on that. Astash, you said if I see logs, use e. No, I said if you see natural logs. On this, you're going to use normal exponents. It's a normal exponent problem. You're going to rewrite it using exponents, and you're going to solve it. Okay, so this is how you would solve that problem. If you see that same looking type of problem, but it's not written with a regular log, it's written with a natural log, you're still going to use exponents. So I'm still going to write this thing. Okay? So what's the difference between these? The difference is this one's got a base of 7. The 2 is going to come over here. The argument, the x minus 3, is going to come over here. 49. 7 squared is 49. You agree with that? Now add 3 to that. 49 plus 3, x equals 52. Look how, wow, that's really, I did that in my brain. Awesome. The base is 7. I can see the base. What is the base of the natural log? The base of the natural log is e, the 2.718 number. The 2 is still coming over here, and the x minus 3 still moves over there. What's the only difference? Kids, I did 7 squared here, which is 49. And then I added 3 because I got to get x by itself. I don't know what e squared is. So go to your calculator, either type in 2.718 or find where the e option is on your calculator and figure out what e squared is. And then add 3 to that. Okay? Just like I did 7 squared and I added 3 to that. See how the answer I got was 52? The other one's the same exact math. I squared it and added 3. I squared 7 and I added 3. I squared e and added 3. It's just 2.718 is like a hard number to do in our brain. So go to your calculator, and what did we get? We got 10.39. So in this case, x would be equal to 10.39. Now, a lot of kids are going to get confused because they see decimals. Uh-oh. Life's not a whole number. Okay? When you invest money, it's not going to be a whole number all the time. So, are these the same exact type of problems? Pretty close. The only difference is when you see a log problem, it's base 7. When you see a natural log, what's the base? Base E. Base 2.718. Okay? Weird, I know. But if you need help, let me know. All right.